Hi all. I just wanted to give a little hint about something that happened in the homework that we didn't cover in class. And that is number 5. So if you take a look at number 5, you have some kind of variation on this problem. Y equals x cubed, y equals 10 minus x, and y equals 0. If you sketch this, you have y equals x cubed, which looks like that. Here, if we pretend that that's 10, you have 10 minus x, and then you have y equals 0. In class, I think we did one where the region that you wanted was here because it was x equals 0. That's not what we want this time. What we want is this region underneath here. It kind of looks like a little triangle, except it's curved on the left. And the problem with that is that it's defined using two different functions, okay? So the first thing I want to do is I need to find this point, okay? Regardless of what happens. So I'm just going to go, these are cubes, so I'm going to go to Wolfram Alpha real quick and have them solve that for me. So I want to set x cubed equal to 10 minus x and let them solve that for me. And you get x equals 2. Okay, so this point is 2. And if you plug in the x value, 10 minus 2, that gives you 8. The corresponding point here is 8. So the y value is 8. Okay, so the issue here is that it's defined differently under here because I'm underneath one part of the one function, and over here I'm underneath another. So that makes it mean that I would have to split things up, okay? In order to get the area, we can do that. So we can say, okay, to find the area, I want the integral from 0 to 2, where it splits, of the function on the left, which is x cubed. And then I'm going to add to that the integral from 2 to 10 of the 10 minus x dx, because that's the line above on the right. And then you can get this value. So this is 1/4 x to the 4th from 0 to 2. And this is 10x minus 1/2 x squared from 2 to 10. Let's see, 2 to the 4th, 16 over 4 is 4. When you plug in the 10, you get 100 minus 50. And then you have to subtract off 20 minus 2. So that's 4 plus 100 minus 50 minus 8. So let's see, that's 50 minus 4, which is 46, it appears. That's my area. Okay, so if your area is 46, then how do we find the centroid? Now, the issue that we have is that it's defined differently on different sides. So I want to avoid using integration with respect to x. So what I want to do is I'm going to think about integrating with respect to y. And so if I do that, then your formulas are going to flip. So with respect to y, you're going to have that your x bar is now going to look like y bar. So it's going to be 1 over the area, integral from c to d, because now we're in terms of y, of 1/2 of your function squared dy. Sorry, it should be a function of y. There we go. And your y bar is going to be the 1 over area integral from c to d of x times y, because we're in terms of y, times f of y dy. Okay, so those are the two formulas that we're going to use. So your setup here is going to look like this. You're going to have x bar is equal to 1 over 46, integral from 0. Now we're going in terms of y. So my y values go from 0 to 8. So 0 to 8, and I want 1/2 times my functions. Okay, now my top function, or my right function, if we're in terms of y, is the line. So that's 10 minus y squared. And keep in mind, so this is x equals y to the 1/3, and this is x equals 10 minus y. And so, yeah, your rightmost function is the line 10 minus y, and your leftmost function is the y to the 1/3. And they each get squared before you subtract. Okay, and you're going to go ahead and simplify and integrate and get your answer. Then your y bar is going to be 1 over 46, integral from 0 to 8 of y times your two functions subtracted. So 10 minus y to the 1/3 dy. And again, you're going to go ahead and distribute your y, find your antiderivative, plug in and get your answers. Okay, so it's a little bit different in that it switches the x's and y's for x bar and y bar when you switch to integration with respect to y.